Hello students, now we are going to discuss a question from electric charges and fields. Here the question is, a charge capital Q is to be divided on two objects. What should be the values of the charges on the two objects so that the force between the objects can be maximum? So for this question, if I assume that one body is having a charge Q, that means I take Q1 to be equal to Q, and the total charge will become how much? Total charge is capital Q1, which is divided into two charges. So here we have capital Q charge, which is divided into two charges. One is Q1, the other is Q2. If I am assuming Q1 as small q and Q2 will become how much? Q2 will become capital Q minus Q. These are the two charges now. One body is having a charge of Q1 and the other one is having a charge of Q2, which is Q minus small q. Now according to Coulomb's law, what will be the force experience between the two charges? It will be 1 by 4 pi epsilon naught into Q1 Q2 by R square, where I assume the distance between the two bodies is R square. Sorry, R. Now, according to that, F is equal to 1 by 4 pi epsilon naught into Q1 value is small q and Q2 value is capital Q minus small q divided by the distance R square. Now, what they're asking you is, what should be the values of, or what should be the values of the charges on the two objects so that the force between the objects can be maximum? For what values of the charges on the two bodies, for what values of Q1 and Q2 will the force be maximum on the between the two bodies? For that, what I take is, there is a condition for that. For capital F to be maximum, dF by dQ should be equal to 0. dF by dQ is equal to 0. This condition is very important. The value of the force between the two charged particles will be maximum when dF by dQ is equal to 0. So that be d by dq of 1 by by 4 pi epsilon naught into q minus q divided by r square is equal to 0. So from which I can take 1 by 4 pi epsilon naught and 1 by r square common out. So what I will get is 1 by 4 pi epsilon naught into 1 by r square into d by dq of q into capital Q minus small q, which is equal to 0. So for which what I'll get is 1 by 4 pi epsilon naught into 1 by r square. I'll send the other side, RHS side, so it will become 0. And I get d by dq of q into capital Q minus small q is equal to 0. From which I can again further simplify it as d by dq goes other side, again it will become 0 here. So that means I'll get q into capital Q minus q square is equal to 0. I take again q other side, so it will become differentiating it. What I get is, sorry, d by dq of differentiating this equation, what I get is d by dq of q is 1, so it will be capital Q minus d by dq of q square is 2q, so it will be 2q, which is equal to 0. And from which I can write it as capital Q is equal to 2 small q, so small q is equal to q by 2. So when you take the value of small q as capital Q by 2, then is when you will have the maximum force that will be experienced by the two bodies. The force experienced between the two bodies will be maximum for the value of small q to be equal to capital Q by 2. In that case, Q1 will become q by 2, so Q2 also will become how much? Capital Q by 2. So if the charge is distributed equally on the two bodies, then is when you will have the maximum force between the two bodies. So hope you understood the solution. Please follow us on for more such questions. Thank you.